Click the bell icon to get latest videos from Ekeeda.
Hello friends, here in this particular video we will learn the non-inverting configuration of operational amplifier. In non-inverting configuration we will learn the mathematical aspect of voltage gain, then applications of non-inverting configuration and its advantages, and where we can use that applications of non-inverting configuration. In the video of configurations of operational amplifier, we have learned how to draw non-inverting configuration. So please take a pause of 2 minutes, draw the non-inverting configuration circuit for operational amplifier, and then again come to me within 2 minutes. This is the circuit on which we have to deal with the analysis of non-inverting configuration of operational amplifier. Second pin is connected to ground through resistance R1, as well as it is connected to voltage VO, output voltage, through resistance, that is feedback resistance RF. Third terminal is connected now, that is non-inverting terminal is connected to input, and that is why we are naming this as non-inverting configuration again. In 741, we are applying 7 and 4 as your DC input signal. Sixth, we are getting the output. Second is inverting and third is non-inverting terminal. Now the fact that you have to note that when you compare inverting and non-inverting configuration, keep this in mind that we have to give feedback to only negative terminal only, and that is why we are using this as an amplifier with a negative feedback. Otherwise, what will happen if we are applying this circuit with positive feedback RF and which is given to positive terminal, then it will give you the oscillatory signals in nature, right? That is called as positive feedback. But we don't want oscillator, we want amplification, right? We want only amplifier. So that is why we are using negative feedback only, even though you are applying input to non-inverting terminal. I hope this is clear with your mind. Then we will do the analysis considering the fact that we know the virtual ground concept. If you don't know virtual ground concept, then follow the link which is mentioned below about virtual ground concept video. We will write here according to virtual ground or short concept. Now here, which concept I have to use? Think in that way. Virtual ground is a subset of virtual short. I know that if we are naming this as V2 and this as V3, from virtual ground and virtual short concept, I know that V2 is equal to V3. But is V3 connected to ground? No, it is not connected to ground, rather V3 is connected to Vi, right? And Vi is neither ground nor infinite. So that is why this is not virtual ground, this is virtual short concept. So here we will not mention this virtual ground here because V3 is not equal to 0. So we will say that this is virtual short concept. According to virtual short concept, I will say this V2 is equal to V3, which is equal to input voltage. So if we apply KCL at this particular node, shall I get the relationship between Vi and the value of Vu? Very easily, because this terminal is grounded. I can get the relation between V2 and VO first, then I know the relation between V2 and VI directly, then we can get the relation between output voltage and input voltage such that we can easily find out the gain. Again, take this circuit. From node A, one current is going here, we will name this as IRF. One current is going here, we will name this as IR1. We will name this as I2. All are outgoing, and outgoing ka summation will be incoming. Incoming is not available, so it's equal to 0. We will write it over here. IR1 plus IRF plus I2 is equal to 0. Simple thing. We will elaborate what is the value of IR1, IRF and I2. I2 as it is negligible. Can say that I2 is equal to 0. We will not mention. And the value of IR1, as it is going away from the node, we can mention that this is nothing but V2 divided by value R1. IRF here, we will mention that V2 minus VO divided by RF is equal to 0. Now I know that as V2 is equal to V3 is equal to Vi. We will put the value of Vi instead of V2. We will be getting Vi divided by R1 plus, we will separate this. Instead of V2, we will again write Vi divided by RF, and minus VO divided by RF we will take on right hand side, VO divided by RF. Okay, so far so well. We will take this Vi common, RF plus R1 divided by R1 into RF is equal to VO divided by RF, right? RF ने RF को मार दिया. So the value of VO divided by VI, that will be getting RF plus R1 divided by R1. I can easily say that the value of VO divided by VI, output voltage divided by input voltage, that we will be getting is nothing but 1 plus RF divided by R1. This is the formula for your gain, voltage gain of non-inverting configuration. Now in this case, one more circuit from this particular formula we can dig out. First is, if RF is equal to 0, what will happen? If RF is equal to 0, I can say that the RF upon R1 is equal to 0. Then in that case I can get to know that the value of VO divided by VI is equal to 1. That means this is nearly same as that of your emitter follower or source follower circuit. This is called as buffer circuit. So in a Viva question, this is very important. When RF is equal to 0, your circuit is called as your buffer circuit. This is called as buffer when gain is equal to 1, then circuit will be called as buffer circuit. So your application of this non-inverting configuration is buffer circuit, and many more circuit as well. In the Schmitt trigger as well, we can have non-inverting configuration. In your adder subtractor circuit as well, we can use non-inverting configurations. So there are so many applications. As we move further for upcoming videos, we will get to know that how many applications are there for non-inverting configurations. Now in this particular video, we have learned about mathematical expression of voltage gain of non-inverting configuration, applications and specific case such as buffer circuit. Thank you so much for watching this particular video. Like, share and subscribe Ekeeda channel. Thank you.